So here we're just going to go through some power functions and graphing them, specifically when we have a function squared or a function cubed. So in terms of our parent functions, which again is our function before any transformations, we're looking at x squared, which is our parabola, and x cubed, which is our cubic function. And those give a nice kind of basic shape for any exponents raised to even and odd powers as well. So let's start with looking at some quadratics, which we've graphed before, and in following videos we're going to do so much more with quadratics again. But just to kind of get started with graphing and thinking in terms of transformations. So the vertex is going to be affected by our horizontal and vertical shift. So this is telling me to go right 3 and down 5. So if our vertex for our parabola is usually at 0, 0, what we're going to do is move that right 3, down 5. So our vertex will now be down here at positive 3, negative 5. So when we've talked about vertex form before, that's what we're seeing here. It's coming from those graph transformations. Now, the next piece we're going to focus on is this 2 out front. So that is going to be a vertical stretch by 2. And because it's positive, we won't have a reflection, so that tells me that we're opening upwards. So typically, from our vertex, we would have like over 1, up 1, over 2, up 4 from the squaring. But now what we're going to have is where we had that vertical distance of 1, that's now going to be stretched by 2. And then where we had a vertical distance of 4 before, now we're going to have 8. So 4, 8, and then some symmetry. And then where we would have a height of 9, we would now have 18. So it just doubles. But with those, we can get the start of our parabola using the vertex from the horizontal and vertical shifts, and then that vertical stretch to tell us how much we're stretching up or down. Okay, with this next one, and for our vertex, we're looking at this +1 and +2. So this one is going to shift left 1. So that's going to bring us over to -1 and then up 2 to +2. So -1, +2. Not there though, up to 2. Okay, and then where we would usually have like 1, 1, 2, 4, 3, 9. I won't have enough space for that one. Now what we're going to have is a vertical compression by 1/2. So we would usually go up to 1. Now we'd be going up to 1/2. So we're shrinking down by 1/2. Where we would usually go up to 4, now we're going up to 2. And where we would usually go up to 9, let's go ahead and graph this, we'd be going to 4.5. So we'd go to 4.5, to 4.5. And with that, we can connect the dots for a nice parabola. So you can see how it gets kind of wider if we have a vertical compression, and then it becomes more narrow as we have a vertical stretch. Okay, let's look at cubic functions. And this one I'm going to need to rewrite as factored out 2, and I could see x minus 2 cubed. So what this tells me is that -2, I'm going to shift to the right 2, so that's my horizontal shift. And this 2, because it's underneath the exponent, this is going to be a horizontal stretch or compression. And as a reminder, it behaves kind of opposite of what we think it would. So this would actually be a compression by 1/2. So we actually want to think of the reciprocal of that value. But no reflections, so what I'm going to do is, usually my cubic function goes through the origin, but we're moving to the right 2 spots. So I'm going to move that over here. And then I would have right 1, up 1, left 1, down 1. And then if I went right 2, I would be going up to 8. So let's go 1, 2, 3, 4, 5, 6, 7, 8. And then similarly 2 to the left would go down 8. So that would be without any sort of vertical stretches or compressions or horizontal stretches or compressions. So we have a horizontal compression by 1/2. So what I'm going to do is where I see this horizontal distance of 1, we're cutting that in half. And then this horizontal distance of 2, cutting that in half. So when I'm saying horizontal distance, I'm thinking from the vertex. So that was a 2, but then we cut that in half. And then same thing down here. So this horizontal compression is going to make this very narrow. In fact, this is going to be kind of difficult to draw, but we'll do the best we can. So we're flattening through the 0 there, and then going off to negative infinity, and then kind of curving through, and then going up to positive infinity. Okay, there's one. Now this one here, let's do similar thing where we'll adjust it first so that we factor out anything inside. So we can factor out a 2, so that's x plus 3, all cubed. So with this one, we're going to go left 3, horizontal compression by 1/2, and reflect over the x-axis. So with that, where we're usually at the origin, we're going to go to the left 3 spots. And then I'm going to do the same thing where I just kind of draw what the parent function would look like just with that shift. So 4, 8, 4, 8. So we are going to have horizontal compression by 1/2. So what we could do is like we did on that previous one. So we're going to bring it in by half that distance. Instead of 2 away, it's 1 away. And then what we need to do is reflect. So this point down here is going to move up here, and this one down here. So what has a negative y value becomes positive, and positive becomes negative. And then same thing over here. And over here. So our function is going to look like this as we go through. So, and just keeping in mind those parent functions as we graph, and then following our graph transformations to get our other points.